Sorry for the disruption. The previous lecture actually got like, it got cut somehow. So it got disconnected and the recording got like, it ended from the middle. So this is the part 2 of the previous lecture. Now, as I was mentioning, we found the integration value here. Now we were integrating between two limits, two like point, one is the upper limit and the lower limit here. So this was the upper limit, and this is the lower limit. Now, after integration, we have seen that we didn't place, or we didn't write any constant c here. We will be coming to that a bit later. But for now, remember, whenever we include limits, okay? Whenever we have limits, we never include a constant c there, okay? Now, we place the upper limit once in the expression. We found the value. Subtracting it with the with the value which we found using the lower limit. So this is the value we found using the lower limit. I mean, we have to place both the limit value to the expression and we have to find them individually and we have to find the difference between them. And finally, we get the area answer between two regions or 2 points. So if we have, let's do an example with a bit, let's say, give me a second. Let me see what better method we have. So let's say we have an expression y equals to x squared plus 4x plus 4. Okay, this is our equation given up to this curve. Now they're asking us to find the area of this area under this curve for this shaded part. Let's say this is our shaded part, and they have mentioned the coordinate over here is as 3. Okay, this is the coordinate of x as 3, and that's the equation. Now use integration to find this area. Now, as I was mentioning, this is not a regular shape. This is not a triangle. This is not a neither like this is a normal rectangle or square that we know the formula to find the area. So integration is the only option we have to find the area. Now use the integration to find the area under this curve for the shaded region. So how can I do that? Simply writing the expression area is equals to integration of x squared plus 4 of x plus 4 with respect to dx, and we need to place two limits. What are the two limits? Where does this shaded region starts from? What is the x coordinate that it starts from? It is 0, isn't it? Because this is the point it gets started with, and this is the final point. So our starting point is at 0, and our final point is at 3. Now, using the normal sum rule and the power rule, we can just arithmetically do the integration here because all are arithmetically added. So we can just simply do that together. We would get x cubed over 3. So incrementing the power with 1 and dividing the whole expression with that power. Plus, we have what? 4x squared divided by what? The power gets also in the denominator. So 2 is the answer. And 4x to the power 1 over 1. So writing that 1 and not writing that 1 is the same thing. And remember, we are not going to include any constant c here. Now writing these limits here, 3 and 0 to the right corners of the right bracket or the ending bracket. Finally, we will just place these limit values in each of the term individually once. So 3 cube over 3 plus 4 times 3 square over 2 plus 4 times 3 minus 0 cube. 0 cube means that is a 0, so 0 over 3 plus 4 times 0 square, that means that's also 0 over 2. And we have plus 4 into 0, that means that's also 0, so we can simply write 0 here. Okay, this whole is what? This whole expression, I mean this right portion is a 0 here. So we don't need to deal with that portion right now. We can like just completely ignore that because that becomes completely 0. But on the left side, like, okay, talking about the right side, 0 divided by anything is what? 0. 0 divided by anything is 0, and like adding 0 to 0 is what? 0. So this whole expression was 0. That's the reason. Now for the last portion, we can simply see that 3 cubed by 3 means what? It is 3 square actually. So that is, we have a 9 to the left side plus this 2 and 4 gets cancelled to get a 2 here. So 2 times 3 is a 9. 9 times 2 is what? 18 plus 4 times 3 is what? 12. So that's 20, 30, 39. So 39 is our final answer. So that's our integrated value. Okay. Now I would give you some homework to do. Won't be able to like continue for the question paper math because it will take a bit more practice to do the question math. So before that, some examples are, let's say we have a curve here from -1 to 2. The equation of that curve is y equals to 3x squared plus 2x plus 4. That's one of the equation. I mean, the one question. Another question is, let's say, it's a bit easy one. So this is y equals to 4x minus x squared. We have another question. Let's say this is 1, this is 2. This we have 3 number. So this is just y equals to 4 minus x squared. We have then number 4 as y equals to 6x squared, and this coordinate is given as 5. And we have a last one, which is this one. Which is this one. So this is the equation, this is the curve given. And the curve has the equation of y equals to 3 x to the power 8 plus 5. Okay. Now, this point is given as 8. Now, in some of the question, I haven't given any of the coordinates. So that means you have to find those coordinates. And if I'm asking you to find those coordinates, that means it's actually easy to find the coordinates using the given equation and the given graphs. Okay, so the information which are here is enough for you to find the solution. I mean the area under the shaded regions. So I'm again saying the expressions here. This is y equals to 3x squared plus 2x plus 4. This is y equals to 4x minus x squared. This is y equals to 4 minus x squared. This is y equals to 6x squared. And this is y equals to 3 times x to the power 8 plus 5. Okay. And this is 4x minus x squared, and this is just 4 minus x squared. Okay. So that's all for today. So do the homework and try it by yourself. You have internet, so use the internet and help from Google. try it by yourself. If you weren't able to solve, then completely fine. We'll be solving it in the next lecture together. Take care. Allah Hafiz. Assalamu alaikum.